One of the things that we kind of stopped doing after Algebra 1, and we probably shouldn't, is checking the solutions that we get when we solve algebraic equations. One of the things we tend to do is we solve, we get an answer, we never check to see if it's right, we just circle the answer and hope for the best. Except when we solve radical equations, and this will pop up again when we're solving another type of equation later in the year, we're going to find out that sometimes algebra gives us an example that actually, or an answer that doesn't actually work in the original problem. That's known as an extraneous solution. It's a good vocabulary word to have. Extraneous basically means extra solution that doesn't actually work. So, how am I going to solve this radical equation? Well, remember the rules of solving radical equations. Number 1, isolate the radical. It is not isolated, so you're going to have to add 5. Well, what happens when you add 5? That doesn't become 5x, does it? It's x plus 5 because they're not like terms. And then step 2, once you've isolated your radical, is to get rid of the radical. We get rid of a square root by squaring both sides. Look at what I did. I know some of you are like, oh, well, that's easy. It's x squared plus 25. No, it's not. Remember that squaring means write it twice and then FOIL it. First, outside, inside, last. So now I get x plus 7 is equal to x squared plus 10x plus 25. That's a quadratic equation. Wow, we spent most of the semester talking about solving those. In order to solve a quadratic equation, you need your equation equal to 0. So I'm going to move the x and the 7 to the other side of the equation. You do that by doing their opposites. So the opposite of x is negative x, the opposite of 7 is negative 7, and notice I line them up with their like terms. So I get 0 equals x squared plus 9x plus 18. Now, in order to solve that quadratic equation, you have a couple of options. One of the options was to graph it in your calculator and find the x-intercepts. That'll tell you your solutions. Another way of doing it is factoring it. That's where you find the two numbers that multiply to give you the last term but add to give you the middle term. Those two numbers are 6 and 3. And then you would use the zero product property to finish solving, and you would find out x equals negative 6, x equals negative 3. I think graphing would have been faster. Now, one of the things I said was to go back and check your answers. So now we're going to go back and check, because I want to show you what's going to happen. So in the original problem, which was the square root of x plus 7 minus 5 equals x, when I check negative 6, I get the square root of negative 6 plus 7 minus 5 equals negative 6, which is 1. The square root of 1 is 1. And I get negative 4 equals negative 6. Does negative 4 equal negative 6? It does not. That means negative 6, not a solution. It's actually called an extraneous solution. So now I'm going to go back and I'm going to check the other answer, which is negative 3. The square root of negative 3 plus 7 minus 5 equals negative 3. So the square root of 4 minus 5 equals negative 3. 2 minus 5 equals negative 3. Negative 3 equals negative 3. Well, that's a true statement. Therefore, negative 3 must be the only solution. Algebraically is not the only way of doing this problem. There was a graphical way on the graphing calculator. what you could have done on the graphing calculator is in y1 equals, you could have put the square root of x plus 7 minus 5, and in y2 equals, you could have put x. And the solution is their intersection. And then the way we do that on the graphing calculator, ooh, I ran out of space to move up. I guess I found a limit. In order to do this on the calculator, you would do second trace, number 5 is intersection, and then you would hit enter 3 times. And you'll notice it'll tell you x equals -3. And that would have been our solution. The nice thing about the graphing calculator is that it will not give you extraneous solutions. It will only give you real solutions to these problems. So only when you do the algebraic problem are you going to possibly find extraneous solutions. Not always, but possibly. These problems, the algebra gets nastier, and so using our graphing calculator might actually be the better solution. But I'm going to talk about how this problem works algebraically anyway, because I want us to practice our algebraic skills. So our first rule about solving radical equations is to isolate the radical. Except what happens when you have more than one radical? Well, this is what I'm going to do. I'm actually going to move that square root of x to the other side of the equation. It doesn't isolate the radical, but at least it makes one side of the equation have only one radical. The next step, we get rid of squaring by square rooting. So the left-hand side, that one's going to look nice. It's going to say 2x plus 1. But the right-hand side, we're going to have to FOIL. Luckily, we've done these problems. We did them in a past section. 1 plus the square root of x plus the square root of x plus the square root of x squared. All right, now I'm going to write this again. These two are like terms. They're 2 the square root of x. Remember, you don't multiply them, you're adding them, so you're only adding the coefficients. And the square root of x squared is x. All right, so now I've got one radical this time. I am going to do this process over again. I'm going to isolate the radical. That means everything else has to go away. So the first thing I'm going to do is I'm going to subtract 1. I'm going to subtract this x. So I have x is equal to 2 the square root of x. If you would like to divide by 2, you can. However, I would just recommend we square both sides in this case. So you get x squared is equal to 2 the square root of x times 2 the square root of x is going to be 4 the square root of x squared, which is 4x. That's just a quadratic equation. So we're going to subtract 4x so that we can set it equal to 0. We can factor out an x, and then we can use the zero product property to finish the problem off. So x is equal to 0 could be one of the solutions, and x equals 4 could be the other. But remember, we have to check them because we don't know if those two solutions work. You will not necessarily always get an extraneous solution. You may get one, you may not get one, you could get 2 and find out that the equation actually has no solution. But you have to check because you just don't know. So, let's use a different color here. So I'm going to start by checking 0. Is the square root of 2 times 0 plus 1 minus the square root of 0 equal to 1? Well, I get the square root of 1 minus the square root of 0 equals 1. 1 minus 0 equals 1, which it does. Okay, so 0 works. Yay, there's one answer. All right, now I'm going to check the other solution. 2 times 4 plus 1 minus the square root of 4 equals 1. That's the square root of 9 minus the square root of 4 equals 1. 3 minus 2 equals 1. 1 equals 1. Hey, look, they both worked. But like I said, you don't know without checking it. Like I said, this was kind of nasty. Maybe this problem would have been better doing it in the graphing calculator. So in terms of graphing, this one's a little bit harder to see. If you graph y1 is 2x plus 1, square root of 2x plus 1 minus the square root of x, and in y2 you graph 1. It's a little bit harder to see the two solutions, but if you play around with it, you can probably figure out where they're at. So an easier way of telling, other than looking at the graph, is to go look at the table. The points of intersection, if you're looking at the table, is where the y values are the same. So if you graph this in your graphing calculator and then go to the table, you'll notice that at x equals 0, both the y values are 1. And then if you look at x equals 4, you'll notice both the y values are, what did they say they were? They were 1 again. But they were both the same, and that's how you know that's where they intersect. So you may want to try it out algebraically, but also try it out graphically on your calculator.